Now, what is an heterocyclic compound? It has a heteroatom. Heteroatom means what? Oxygen, nitrogen, sulfur as a part of the ring. So if I replace one of the CH by nitrogen, right? So this becomes my heterocyclic compound. So it can be 5-membered ring, it can be 6-membered ring, it can be 3-membered ring, whatever it is. Okay. In heterocyclic also you have aliphatic and alicyclic and aromatic compounds, compounds which are not aromatic. So such compounds also come under the class of heterocyclic compounds. Okay. We are going to talk about heterocyclic aromatic compounds. And pyridine, pyrrole, furan, you people have already done in your lower standards. Yes or no? Okay. So here we are going to study new heterocyclic compounds, and there are three compounds that are there in our syllabus. So uh, this is pyridine. What is pyridine? This is pyridine. Yes or no? This is your pyridine. And if you have an oxygen attached to it, this becomes pyridine N-oxide. This is called as what? Pyridine N-oxide. What does that mean? That oxygen is attached to nitrogen. So this becomes a N-oxide. Now, can you tell me what will happen to the charges? Come on. Will it be charged, or what it will be? Hmm? Nitrogen has formed an extra bond. Okay. It has formed, what is the valency of nitrogen? 3. Now it has formed a fourth bond, right? So it has utilized the lone pair. Nitrogen has a lone pair of electrons. So it has utilized that lone pair to form a bond with oxygen. Yes or no? So because the utilization is there, nitrogen will have a positive charge. And oxygen, how many bonds oxygen has? Oxygen has two bonds, yes or no? So only it has formed one bond, it's a coordinate bond. So oxygen has that lone pair of electron on it. So it becomes what? Oxygen has its electrons on it. So this will be having a negative charge. So just remember the pyridine N-oxide structure. Okay, this is one. Then we are going to study about quinoline and isoquinoline. Okay, these two compounds. So what do you mean by quinoline and isoquinoline? Imagine you have your pyridine ring. Okay, so this is your pyridine ring. Fine. I will not draw the bonds right now. Now this pyridine ring, when you attach it to the benzene ring. Okay, this is your benzene ring. Fine. So when you attach this pyridine to the benzene ring, this is called as what? Quinoline. Is that clear to you? Okay. And what do you mean by isoquinoline now? Now, if I number this quinoline as I'll start the numbering starts from the heteroatoms. So this is one, two. I hope you people are having your books with you. Don't just look at the screen, huh? Hello? Don't look at the screen. Are you having your notebooks with you? Keep the so write down what, yes, very good. Write down as we are writing everything, okay? So this is position 1, 2, this is 3, this is 4. Now this is the bridge one. This won't get a position over here in such compounds. So 6, 7, 8. So see how the numbering is done. Fine. Now this we will draw a similar structure. The only difference is, you tell me what is the difference. What is so- what is the difference over here? Can you tell me? Mhm. Nitrogen is on which position? Second position, no? Nitrogen is on No, don't say meta and everything now. uh, nay, orthometa will be with respect to what? Yeah, the position. That's right. So this position, so 1, 2, 3. Now see, I said that vitrocyclic compounds numbering starts from what? Nitrogen. But now in this case, isoquinoline, the position for isoquinoline will be second position only. Okay. Nitrogen will be second position. Fine. That is why it is iso. So 3, 4, this is 5, 6, 7, and 8. Have you understood the three structures that we are going to study? Pyridine, quinoline, and isoquinoline. So what exactly we are going to do is, we are going to study all these compounds in the form of, uh, we are going to study their preparations. Okay, we will study the resonating structures. Fine, resonating structures, and we are going to study their reactions. Is that clear to you? So we will be taking one by one compound and studying each one. Fine. So let's start with the simplest one. Let's go for pyridine. Okay. So pyridine N-oxide, sorry. Hmm? So write down the first one is pyridine N-oxide. Okay. Pyridine N-oxide. Fine. Written. Now we will do first its preparation. Okay. So can anyone tell me what is the easiest way? Just think of it to prepare pyridine N-oxide. Can anyone guess what could be the easiest way? किससे मिलेगा pyridine N-oxide तुमको? सबसे इजी मेथड क्या हो सकता है? Hmm? You have pyridine. Suppose, okay, I'll give you a hint. It is prepared from pyridine. कैसे प्रिपेयर करोगे? चलो बताओ, सोचो. Pyridine say pyridine and oxide. What is the difference between the two? Oxygen. You want to add an oxygen over here. How will you do this? What method will you use? Hmm? Yes, students. Which method will you use? Oxidation. Yes. So the preparation is nothing but what? Oxidation. Very simple because you are just adding one oxygen. No? Yes or no? So, for oxidation, nascent oxygen is enough, and the oxidizing agents that are used, that could be hydrogen peroxide. Either this can be used, or we can use peracid. Okay, so peracid is nothing but CH3 COOOH. What do you mean by peracid? Now, what is the structure of hydrogen peroxide? HOOH. This is the peroxide group. This is the peroxide linkage. And when we say per acid, so we know carboxylic acid, right? This is your acetic acid. Now what we do is we insert one oxygen over here. So one oxygen and this is the OH. So this becomes your peroxide linkage. Getting it? This is the per acid. And this oxygen is removed and it gets as a nascent oxygen. So if you are using H2O2, the byproduct will be water. If you are using per acid, if you remove this oxygen, what would be your byproduct? Yes, anyone? What would be your byproduct? Acetic acid. Yes, that's right. Yes, that's right. Okay. So either of the reagent is used and this is the oxidation. Fine. So just write it down and then we will go for its resonating structures. Fine. Come on, write it down. So once you're finished, let me know. Resonating structures. Okay, now you people have studied resonating structures, right? So in your lower standard. So you will help me now for writing the resonating structures. Fine. So let's start. Let's start with the simplest one. Okay. This is coordinate bond. Oxygen negative, nitrogen positive. Draw the bonds the way you want. Okay. Now this is our first structure. Let's number this ring. Okay. Let's number it. So nitrogen 1, 2, 3, 4, 5 and 6. Okay, is this clear to you? Now, how to write the resonating structure? What is the first thing that we will do? Yes, anyone? What do we do in resonance? We shift the bonds. Resonance means what? The pi electrons are shifting, but the positions of the atoms remain the same. Yes or no? Now there is this positive charge over here and there are pi electrons. So what will happen in first step? These electrons will shift to nitrogen. So if these electrons shift to nitrogen, come on, now all of you try to write the first structure. Okay, if these electrons shift to nitrogen, the electrons on the nitrogen are restored. So the positive charge on the nitrogen will be removed, and the electrons, see, nitrogen always has a lone pair of electrons. When it forms three bonds, the lone pair of electrons is intact. When it forms the fourth bond, okay, like in this case it is forming a bond with oxygen, now the lone pair of electrons is utilized because it like the overlapping takes place. So this is the empty orbital of oxygen or whatever it is, and that nitrogen with the lone pair of electron, it has now donated, or it has shared its lone pair of electron with the empty orbital of the other element. So there are no electrons on nitrogen now. Because there are no electrons exclusively on nitrogen, nitrogen gets what? Positive charge. Now if you break this or somehow break that fourth bond, and what will happen? The electrons will come back on nitrogen. So will there be any positive charge when it has three bonds? No, it won't have positive charge. When nitrogen has four bonds, it will be having a positive charge. Remember this every time, you remember this, okay? Whenever the extra bond is there, that means what? The lone pair of electron has been utilized. So nitrogen has a positive charge, and when it has three bonds as per its valency, the lone pair of electron is on the nitrogen, so it won't have any charge. So the same thing happens over here. When these two electrons shift to nitrogen, there won't be any charge on nitrogen, so nitrogen will remain as it is. Are you getting this? Now both these electrons are now coming to nitrogen, so nitrogen has got its electron back. What will happen to this charge at the sixth position? Anyone? Can anyone tell me? See, you can number it this way also or this way, huh? Because there is no other substitution. So from both the sides you can number. So this can also get the second position. Now if you want, you can call this as ortho, meta, para. Okay. So what would be the charge at this position? Can anyone tell me? Positive, very good. So this will, yeah, this will be positive, right? And what happens to the remaining structure? It remains as it is. Is that clear to you? Have you understood this? Okay. Now, can you draw the third structure? I shall rub this part. Hmm. Third structure बोलो क्या कैसे लिखेंगे? So the same thing. क्या है? So let's draw first the ring. Okay, nitrogen. Now, until these electrons are not disturbed, this will remain as it is. Okay. So now what happens? These two bonds shift over here. See, shifting takes place, right? So if these two bonds shift over here, this will now, ये bond तो वैसे ही रहेगा, yes or no? Now because this bond has shifted over here, this charge will be positively charged, right? Okay, come on. Now draw the next structure and tell me what do you get. कहाँ से शिफ्ट करूँ मैं? Just for the sake of understanding now, just follow these numbers. So tell me where will be your positive charge and where will the double bond shift? Tell me. पॉजिटिव चार्ज थर्ड पोजीशन पे नहीं रहेगा ना, दिस इज फोर्थ. हाँ यस, ये ऐसे शिफ्ट होगा ना, हाँ. तो ये इलेक्ट्रॉन तो इधर ही है, ये इलेक्ट्रॉन इधर चला जाएगा, बराबर. तो तुम्हारा पॉजिटिव चार्ज कौन से पोजीशन पे आएगा? सेकेंड पोजीशन पे, एंड दिस विल फॉर्म अ डबल बॉन्ड. हाँ यस, दैट्स राइट. ठीक है. नाउ ये हो गया एक सेट ऑफ रेजोनेटिंग स्ट्रक्चर्स pyridine N oxide का. नाउ जस्ट सी द फन, इट विल ऑल्सो हैव वन मोर सेट. तो हाउ यू विल गेट दैट? ओके. सो this oxygen is there, right? इसके ऊपर भी electrons है, yes or no? So what this oxygen will do, this oxygen can also participate, these electrons can also participate in the resonating structures, yes or no? So even instead of now in the first set, what we did, we shifted these electrons, right? Now let's see the second set where we will shift these electrons from, because these are also electrons, they are also eager to take part in the resonance. Okay, so if these electrons shift, what will be your structure? Anyone? अगर यहाँ से ये electrons मैंने shift किया, तो you're going to get something like this. Now oxygen के दो bonds आ गए, so there won't be any charge on oxygen. Nitrogen has got its electrons, so what happens here? Yeah, how many bonds will be there? Now, if these electrons shift over here, now I'll just rub this. Okay, if these electrons shift over here, फाइन यहाँ से ये इलेक्ट्रॉन्स आ गए तो दिस बॉन्ड सी इफ आई राइट द इलेक्ट्रॉन्स तो अगर आई कैन नॉट राइट दिस बॉन्ड नो बिकॉज नाइट्रोजन के पास कितने बॉन्ड्स हो गए देखो 1 2 3 4 5 दिस इज नॉट पॉसिबल सो व्हाट हैपेंस इज these electrons they move and come at this position see how the resonance is taking place so there won't be any electrons over here now how the structure will look like the electrons are coming over here so it will have electrons over here so nitrogen का positive charge वैसे ही रहेगा and this will be the negative charge over here and the remaining structure will remain as it is so far have you all understood this structure yes students see and if you observe in resonating structures the plus minus charges are always neutralized huh? Okay, now can you shift now tell me come on any one of you just unmute yourself and tell me next structure क्या draw करूं मैं बाकी का सब तो वैसे ही रहेगा नाउ हु इज गोइंग टू मूव नाउ टेल मी व्हाट शैल बी द मूवमेंट ऑफ द इलेक्ट्रॉन्स अभी कौन से इलेक्ट्रॉन्स पार्टिसिपेट करेंगे ये इलेक्ट्रॉन्स ना सो दीज टू इलेक्ट्रॉन्स will now come here and form the bond and these two electrons will shift over here see drawing resonating structure is quite fun once you get a hint of it how to do that it is very fun to to draw these resonating structures ठीक है तो यहाँ पे ये नेगेटिव चार्ज आ गया यस और नो चलो अभी यू टेल मी द थर्ड स्ट्रक्चर कम ऑन वेयर विल द इलेक्ट्रॉन शिफ्ट नाउ यहाँ सी ऑलवेज फॉलो ओनली वन डायरेक्शन अगर मैं यहाँ से कर रही हूँ तो ये डायरेक्शन फॉलो करो तो आगे का स्ट्रक्चर विल चेंज द प्रीवियस स्ट्रक्चर विल रिमेन एज इट इज नाउ टेल मी व्हाट विल हैपन टू दिस एनीवन हाँ तो 4 3 मतलब ये ना हाँ सो यहाँ पे इफ यू फॉर्म अ पाई बॉन्ड between 4 3 तो okay then what happens to this bond अगर तुमने यहाँ पे बॉन्ड फॉर्म किया तो ये बॉन्ड ऐसे रहेगा क्या यहाँ पे नहीं ना हाँ it will shift yeah it will shift to which position second position that's right yes so these two electrons over here these two electrons will shift over here yes or no so now you are going to get the electrons over here so यहाँ पे तुम्हारा negative charge आगे जाएगा right yes or no and now then you can restore the structure in either case यहाँ पे कैसे हो जाएगा फिर so if you want to restore the structure this these two electrons will shift over here and this will be back so see the difference between the first structure and this structure now shifting has taken place yes or no so the even this structure will also give you the same thing okay okay students have you all understood this क्योंकि ये यहाँ से जाएगा फिर ये ultimately it will go through this whole thing and you are going to get this now what you have to do just look at the two structures all the resonating structures and you people tell me where are the positive and the negative charges in the whole structure where are the positive charges at which positions नाइट्रोजन का छोड़ दो on the ring where are the positive charges ये छोड़ दो on the ring हाँ मेटा एंड ऑर्थो सो दिस इज विच पोजीशन इफ आई से दिस इज टू अगर यहाँ ऐसे इसी पोजीशंस को तुम लोग कंपेयर करोगे सो दिस इज व्हाट दिस इज टू यहाँ पे है yes or no positive charge is over here it is over here and it is over here yes or no so where are the positive charge 2 4 and 6 yes or no हाँ ऑर्थो पैरा एंड नेगेटिव चार्जेस कहाँ पे है जस्ट चेक where are the negative charges same positions ना see here where are the negative charges यहाँ पे एक है यहाँ पे है and here it is so which are these positions again 2 4 6 yes or no Okay, that means in pyridine N-oxide, you have positive as well as negative charge on the same positions. Okay, now which type of reactions will this show? Will it show nucleophilic substitution or electrophilic substitution? See, aromatic compounds, they undergo substitution reactions very easily. They don't undergo addition reaction in spite of the double bond. Okay, because they are more stable and they can undergo substitution. So, will it undergo nucleophilic substitution or electrophilic substitution? Nucleophilic means what? Negative charge is replaced by negative. Electrophilic is positively charged electrophile will attack. So, you tell me which type of substitution will pyridine N-oxide undergo? Nucleophilic substitution, negative charge is going to attack on which atom? Nucleophilic मतलब क्या? Negative charge nucleophile attacks on positive charge. ओके अभी नाइट्रोजन के पास कुछ नहीं है नाइट्रोजन ऑलरेडी एग्जॉस्ट हो गया बॉन्ड फॉर्म करके तो नाइट्रोजन पे अभी कुछ बॉन्ड फॉर्मेशन नहीं होगा द बॉन्ड फॉर्मेशन विल टेक प्लेस ऑन द रिंग सो ऑन द रिंग इज देयर अ पॉजिटिव चार्ज yes so nucleophilic substitution can take place yes or no and where is the positive charge 2 4 6 that means nucleophilic substitution will take place at which position 2, 4, and 6. Yes. Similarly, what does an electrophile do? Electrophile is a positively charged species. Yes or no? Positively charged electrophile attacks which position? Attacks negative charge. Yes or no? Electron loving. It will attack negative charge. So is there negative charge on the ring? Forget night oxygen. Oxygen पे अभी कुछ नहीं हो सकता. On the ring. Is there a negative charge on the ring? Yes or no? Yes. Where is the negative charge? 2, 4, 6. Matlab this will also undergo electrophilic substitution? Yes. So it undergoes what? Both nucleophilic and electrophilic substitution. So write this down. Pyridine, write this down. This is your MCQ question. Pyridine N-oxide, pyridine N-oxide undergoes both nucleophilic nucleophilic and electrophilic substitution at which positions at which positions 2 4 and 6 position yes that's right okay ठीक है हाँ okay ortho para चलेगा written now once you know where the reaction is going to take place so let's write down some reactions. So in one chart only, no, we will write down all the reactions. So it will be easy for you to learn the whole reactions. And how you're going to study in the exam, you are going to study the reagents and what reactions they show. ठीक है? So just make this type of chart, take a whole page and take a new page now and you people are going to tell me what are these reactions. Okay, so we will write one by one. Okay, so the first reaction that we are going to start with is halogenation. In halogenation, let's take example of chlorination. Okay, chlorination. Hmm? Okay. Now, this is an example of electrophilic substitution. Fine. So, electrophilic substitution takes place at which position? 2, 4, 6. Nucleophilic also takes place at 2, 4, 6. When we say electrophilic substitution, what exactly is getting substituted is the H. Yes or no? What is getting substituted? This H, which is positively charged, it is getting substituted by another electrophile. So, what will your reaction look like? What will be your product look like? Hmm? कैसे दिखेगा ये नाइट्रोजन एन ऑक्साइड हाँ yes Cl will get added no Cl will get added so this will be Cl over here so this H and Cl how we will write this way. So this H and Cl, this undergoes electrophilic substitution very easily. So this you will get, and you generally get a mixtures. Okay, so you will also get Cl over here. So can you name these compounds? Can you name it? What would we call this? This is 2-chloropyridine N-oxide. Okay, and this is 4-chloropyridine N-oxide. Have you understood this? Can anyone tell me which one could be a major product? Hmm? Which? Para, yeah, that's right. What could be the reason for that? Steric hindrance. नहीं, steric hindrance है क्योंकि यहाँ पे ऑक्सीजन है. ओके, स्टिल Cl is a comparatively smaller group, but दूसरे इलेक्ट्रोफाइल्स के लिए para will be a major product. Okay, so what you will learn is halogenation. What is an halogenation? Example of electrophilic substitution. So in exam you may get questions this particular reaction whether it is electrophilic or nucleophilic. Okay, now you people tell me what is nitration? Is it electrophilic or nucleophilic? अच्छा, नाइट्रेशन में तुम लोग कौन सा ग्रुप ऐड करते हो? NO2 पे चार्ज क्या है? प्लस, नो? What is this called as? What is this called as? Nitronium ion. Nitration gives nitronium ion. What is the charge on nitronium ion? Positive charge. Yes or no? So this is again an example of what? Electrophilic substitution reaction. And can anyone tell me what are the nitrating agents we generally use? Yes. Yeah, so we can use concentrated HNO3 and we can have NO2 gas in it. Okay, we can use mixture of concentrated HNO3 and concentrated H2SO4. Yeah, this is called as a nitrating mixture. Fine. Okay, so tell me what would be the product. Always remember for all these, you always get a mixture. So this is plus. Where is your reaction going to take place? Yes, the reaction now exclusively, this pyridine. Yes, tell me first what are the products, then we will tell me what are the products. Hmm? What are you going to get? ये pyridine and हाँ, two nitropyridine N-oxide. Okay, and what else you can get? हाँ, अच्छा, ठीक है. So अभी इसमें which one will be major product? 4-nitropyridine N-oxide, yes. So this will be, yeah, 4-nitro, write down, 4-nitropyridine N-oxide. And mostly this is a highly major product, around 90-95% yield रहता है इसका. And hardly you get any uh, second this thing, 2 wala product. Okay, fine. Have you understood this? Okay, and the good thing about these reactions is what we also do is like sometimes halogenation and bromination on pyridine is very difficult. Okay, so instead of doing halogenation and bromination on pyridine, what we do, we first prepare pyridine N oxide, then we do the halogenation, and we can also अगर आपको pyridine फिर से चाहिए, okay, so we want to convert this to pyridine. So halogenation on pyridine was not easily possible, no? So what we did is we converted it to this, and then we removed the oxygen. ठीक है, so we generally use a reducing agent like zinc. So now you get 4-chloropyridine and zinc oxide. So activity of pyridine and oxide is more than pyridine. Reactions which were not taking on pyridine directly can take place when you convert it to pyridine and oxide, and then we can bring back the pyridine again. Are you getting this? Okay. So this is one way of preparing, uh, you know, uh, chlorinated pyridines. Uh, Fine, because it's like pyridine, direct pyridine may not be, halogenated pyridine may not be possible. So we may get something like this. Fine. Okay, now let's go for the next reaction. Uh, Two more reactions, and then 6 unit students can leave, and only 3 unit students will stay. Okay. So आज ये pyridine का चीज हम लोग कर फिनिश कर देते हैं. Then next reaction is amination. Can you tell me what is amination? Amination मतलब क्या? Which group are we adding over here? Amine. NH2. Yeah, NH2 group. What is NH2? Is it a nucleophile or an electrophile? Nucleophile, because NH2 is obtained from what? NH3, right? So if I remove this hydrogen, I'm going to get NH2. Now H is positive and N is negative. So I am removing this. So negative charge will stay on nitrogen over here. So this is what a nucleophile. So this is an example of what? Nucleophilic substitution reaction. Yes or no? Hmm? So come on, quickly write down the product. Okay. I'll give you what is the what which reagents are used. In this, the reagents used are NaNH2. What is NaNH2? Write down the NaNH2 है. Okay, sodamide, NaNH2, sodium amide, and liquid, हाँ, NH3. ठीक है? So in this case, you get two products basically. Here the substitution also takes place at third position. The stabilities are different, however. Okay, so you basically get a mixture of 2 amino pyridine N-oxide. Unlike fourth position, here the substitution is taking place at 3 position. Okay, so again you get a mixtures of these compounds. Fine, and one more reaction. So fourth one, ये मैं रब कर देती हूँ. Write down the last reaction for pyridine N-oxide. Okay, this is with N-butyl lithium. You remember in the last lecture we had studied uh, where we use this N-butyl lithium. When you use this, acha, tell me first whether this will be nucleophilic or electrophilic substitution reaction. Okay, see now what happens is when you use N-butyl lithium, this lithium generally these compounds are used as intermediates to prepare intermediates if you want to have a substitution. Okay, so at ortho position this lithium goes, and this is not our product, we are using this to prepare an intermediate for further reactions. And here if you want to prepare carboxylic acid, if you want to bring a carboxylic acid group, generally this reaction is easy. So this is how the reaction takes place. So just note it down. This Li group will break, and in this case COOH group will come. Okay. This is pyridine N-oxide to carboxylic acid. Fine. So far, we will just stick to this only. We won't go for the quinoline and isoquinoline structures. Fine. So if you have finished writing, have you all finished writing? Hmm? Okay. So just wait for a. I will share these notes with you in both the groups. Okay. Let me first finish quinoline and isoquinoline also. All these, or it's the same thing that I'm going to post in the group also. A few extra points we will see if they are there or not. Acha, tell me this is whether this is electrophilic or nucleophilic substitution. Hmm? Lithium, electrophilic, because lithium will be having a positive charge. Yes or no? It's more positive than carbon. So it will be having, so when the bond breaks, lithium will be having positive, the carbon will be having the negative charge. So lithium is getting substituted over here. Hence it will be electrophilic substitution. Yes or no? Okay. So I will just stop